For example 1, what we need to do is find the general term for each series. We're going to look for patterns. And for part A, one of the patterns we see is we can look just at the numerator position, and we see that a 5 is staying the same. So we know that our general term is going to have a 5. In the denominator, we can see that we have a 1. We have a 1 times 2, 1 times 2 times 3, and you can imagine the next one would be probably 1 times 2 times 3 times 4 if this pattern continues. Well, this is just n factorial in the bottom. And so our example here is going to be 5 over n factorial. For the third term, if we try this, that's 3 factorial, which is 3 times 2 times 1, or 1 times 2 times 3. Same thing. So this does work. You can check it either mentally or on paper. Some of them are pretty easy to check mentally, but you should do that every single time. For this next one, what we need to do is we need to rearrange some of these fractions first. I see a 1, a 3, a 3, and a 1, which, maybe that's a pattern, but it doesn't seem like it's going up by the same thing, or being multiplied by the same thing, or any squares or anything like that. And we've got 5, 7, and then jumps down to 3. So one trick with these fractions here is to rearrange them, and we're going to rearrange these in terms of, let's see, 1 I'm going to rewrite as 3 over 3. The reason why I'm making that decision to rewrite that as 3 over 3 is because if we could just get all the numerators to be the same here, then our general term would just have a 3 in the top, so that's one thing to try. And then I'm also noticing that if I can rewrite this as 3 over 3, that the denominators will then just go up by 2 every single time. And then 1/3 here can be rewritten. We're going to try to rewrite this with a numerator of 3 again, see if we can get all that the same. And then 1/3 would be the same as 3 over 9 if we had to write that 3 there. So this is going to continue on, and all we need to do is find the general term here. Well, now that we've rearranged this a little bit, or at least maybe not rearrange, but just rewrite these terms here and here, it does make sense. So you're going to have a 3 for the general term in the numerator. It's the same. And then in the denominator, we have a nice little arithmetic sequence. If you're having trouble figuring out what this is, you can use your formula for the general term. We're just going to plug that in here. So the general term for this guy is going to be a sub n is equal to a sub 1, which we're looking only at the denominator here, is 3. And then d is 2. Remember, d is the thing that we're adding every single time, which could be negative, but in this case is positive. And then n minus 1, n is going to stay the same. We can do a little distributive property here. So we've got 3 plus 2n minus, that's a 2. And then in this case, we're going to do 3 minus 2, which is 1. And I prefer to write the term with the variable first here. That's the way that you're going to see it written, in a nice communication tool. So we've got 2n plus 1 here in the denominator only. And just to double check, this is the fourth term right here, or 3 over 9, or 1/3. And so for the fourth term, we'd have 3, and that would be over 2 times 4. Remember, n is 4 here. It's our index value. And that is 3 over 8 plus 1, which is 9, or 1/3. So this does work. It's important to check to make sure. Sometimes it's easy to maybe make this a -1, or I almost forgot over here to do the distributive property after I told you I was going to do it. So you would figure out pretty quickly, if this was a 2 here, if I made that a -1 and made a mistake, that it wouldn't be right. It would be 3 over 10 in that case. So just do a quick double check just to make sure.